Question 6. Elizabeth's Bakery makes brownies. It's known that the mass X grams of a brownie may be modelled by a normal distribution. We're told 2 facts here. We're told that 1 in 10 brownies, i.e. 10%, have a mass of less than 30 grams, and that 80% have a mass greater than 32.5 grams. We need to find the mean and the standard deviation. So we don't know the mean, we don't know the standard deviation. So therefore I need to use the standard values, or the Z values, if you will. So we've got 2 pieces of information here. And we'll do 2 little sketches. We know that 1 in 10 brownies have a mass of less than 30 grams. So that means 10% are less than 30 grams. Okay, so that's going to be at the bottom end of this normal distribution. You're also told that 80% of them have a mass of greater than 32.5. So I know that 80% are larger than 32.5. Also, I could state that 20% are less than 32.5. I need to use the standard normal, as I mentioned before. So we need to use this formula, okay? Z equals X minus mu over sigma, where Z is your standard values. It's how many standard deviations away from the mean a value is, and X is what the actual value is. So what we need to do before we use this formula is we need to find these Z values. So firstly, I need to work out how far away from the mean 30 is, okay, in terms of standard deviations. Same with the 32.5. So I'm going to need to use inverse normal to do that, because I know the probability that big Z is less than little z equals 0.1. So I need to find out how many standard deviations away from the mean you need to be in that bottom 10%. And then similarly here, but instead of doing big Z is greater than little z equals 0.8, remember when I use inverse normal on my calculator, I need to consider the area to the left. Now I know in my classes before I've sometimes done Z and K here, because I know it can sometimes get confusing with the capital Z and the lowercase z, but I'm going to try and be consistent what you might have done in other classes. So I'll just get on my calculator, I go menu, 7 and inverse normal. And then firstly we're going to do the first part of this. The area is 0.1. Because it's standard normal, I put in a standard deviation of 1 and a mean of 0. Work that out and we get that Z is minus 1.2816. I'm going to try and be quite accurate here and go to 4 decimal places. I do a similar thing for the second part of this. So I put in the area 0.2. Okay, don't put in 0.8 because that will tell you the kind of the value that's symmetrical to that 32.5, but in the upper tail here. So we need to put in 0.2, not 0.8, because remember, it's only ever going to tell you when you put in the area there, it's referring to the area to the left. So we get Z as minus 0.8416. So I'll write that down. And we expect negative numbers here. And the reason being we expect negative numbers is because both 30 and 32.5 are below the mean. So now what I'm going to do is use that formula that I mentioned. You do get it given in the formula book. So I'm going to put in Z and X now. So Z is minus 1.2816. X is going to be 30. And mu and sigma are what I'm trying to find. Do a similar thing for the second part of this. And remember what this means. That Z is minus 0.8416. It means that the number 32.5 is 0.8416 standard deviations below the mean. Okay, so that's why I said you expect negatives in both of these. With a little bit of rearranging, what I'm going to do is I'm going to times both sides by sigma for both of these equations and add mu. So when I do that, I get minus 1.2816 times sigma plus mu equals 30. And I also get minus 0.8416 times sigma plus mu equals 32.5. So we've got two equations with two unknowns, so we are going to solve them simultaneously. So I go on to equation / function on my calculator, go to simultaneous equation, two equations we've got here with two unknowns, and then we just simply put them in here. So my x is going to be sigma here essentially, and what I put here, just put a 1 here in front of the y, okay, because that's the coefficient of mu, and then put my 30 here. So just make sure it's ranged in the correct way. And just put this information in. I'm going to do this. I get a standard deviation, because that's my x, of 5.68 to 3 significant figures, and I get 37.3 for my mean. So then I get 5.68, and I got 37.3 there. Okay, you can also put these values back in, check that they work, check they make sense, if you do have the time, obviously. But that's how you do get all 7 marks there for that first part of this question. So then there were extra bits to this. So we have part B, where we need to work out the probability that x does not equal 35. This was a really poorly answered question. And I think what a lot of you did was you thought, well, what would I do if it was binomial, for example? With binomial, so a lot of you thought of this as 1 minus the probability that x equals 35. With binomial, it's discrete, so it can only take on certain values. But normal distribution is continuous. It can take on any value within that range. One way of thinking about this is, let's just take people's heights, for example, that are normally distributed. If I said to you, in a group of people, what's the probability that you find someone with the exact height of 173.2682543200338 centimetres, well, that probability would be 0. So with normal distribution, we never use it to find individual values. We only use normal distribution to find the probability that is in a given range of values. I mean, you could say that you'd have it rounded to nearest integer and do 34.5 to 35.5, but with normal distribution, the probability that x equals a particular number is 0, so the probability that it doesn't equal 35 is just going to simply be 1, and that's all it is for that question. With A-level maths, we will never use normal PD. Okay, we will always use normal CD. The probability that x equals a particular value with normal distribution is 0. Okay, so this basically means what's the probability that you find, if you flip this on its head and think about the probability that x equals 35, that means you find the probability you find a brownie that is exactly 35.00000 grams. Okay, you could also think about it, if you do it binomial CD, you could do it ranging between 34.99999 and 35.000001, and your calculator should give you 0 there. Part C now just uses what we worked out in part A. So you do get follow-through marks for this, so if you did get incorrect standard deviations and means, as long as you've had a valid attempt and your answers make relatively pretty much make sense there, then you'll still get this follow-through mark for both follow-through marks, sorry. So we just go normal CD here. We just put something like minus 10,000 here, and we put upper of 35. Your standard deviation is 5.68, and your mean is 37.3. Okay, and when we do that, we get 0.343 to 3 significant figures. Okay, it depends on what you've used for your standard deviation mean, depends on how you've rounded here. But the mark scheme does allow you to kind of be within a given range, dependent on what your values are from earlier. The final part then, brownies are baked in batches of 13. Calculate the probability that in each batch of brownie no more than 3 brownies, so I like that, are less than 35 grams. You may assume that the masses of the brownies are independent of each other. So to me, this seems like a good time to use the binomial distribution. We've got a fixed number, 13. The probabilities are independent of one another. Either the batch is going to be less than 35 grams or greater than 35 grams. Okay? Or no more than 3 brownies are less than 35 grams. So we set up a binomial here. We have n is 13. And then our probability, well, we've just worked that out from before it's 0.343. So we've got that fixed probability. Yet again, you'll get follow through marks. So whatever you got in this question here, you'll get it follow through here. I think a lot of people got 0.344, which is absolutely fine as well. The mark scheme is lenient in terms of that, as long as you have been rounding to 3 significant figures as you've gone along. So then we just go menu 7 and binomial CD here, because we want the probability that there's no more than 3. So we need the probability that it's 3 or less. So I put x as 3 here because I need to include the 3. And then n as 13 and p as 0.343. Hit equals. I get 0.296 when I do so. Yeah, again, depending on what you have here for your probability, it may differ slightly. I think if you put 0.344, you end up getting 0.294. And that's how we'd answer that question. So just always be a lookout for, especially this bit where it says less than 35 grams. You should be thinking, have I just already worked that out? And then this is where you need to think of this as a binomial distribution.